Today, we're looking at a huge problem in the software that runs our world: hidden security bugs. Even in the most popular apps and systems, tiny errors in the code can open the door for hackers.
Exactly. And we're talking about a particularly nasty type of bug called a memory safety vulnerability.
That sounds technical. Break it down for us.
Imagine a computer's memory is like a giant wall of mailboxes. When a program runs, it gets assigned a specific set of mailboxes to store its information. A memory safety bug is when that program accidentally reads from or writes to someone else's mailbox.
Ah, so it's messing with data that doesn't belong to it. What happens then?
Best case, the program crashes. Worst case, a hacker can exploit that mistake to take control of the system. This is a massive issue in older but still essential programming languages like C and C++.
For decades, we've tried to find these bugs with methods like manual code review and something called fuzzing. Fuzzing, that's where you just throw tons of random data at a program to see if it breaks, right?
Yep, and it works up to a point. But many clever bugs still slip through, even in software that's been fuzzed for years.
Which brings us to today's paper. It uses AI, specifically large language models, or LLMs, the same tech behind tools like ChatGPT. The idea is that these AIs can read and understand code like a human expert, finding bugs that other methods miss.
But there's a catch. Two big ones, actually. First, using the most powerful AI models to scan a massive software project is incredibly expensive. And second, LLMs are famous for making stuff up.
They hallucinate. An AI might report a critical security bug with great confidence, and developers spend hours investigating, only to find out the bug doesn't exist. It's a huge waste of time.
This is where the paper called Revelio comes in. The researchers from UC Berkeley created a system that is both cost-effective and trustworthy, and their core idea is a brilliant two-stage process.
Okay, I'm listening.
Think of it like a detective agency. In stage one, they use a cheap junior-level AI. Its job isn't to be perfect. Its job is to be fast and thorough. It scans every single file in the project and flags anything that looks even remotely suspicious.
So it casts a really wide net. It's going to have a lot of false alarms, right?
Tons of them, and that's fine. This first stage is all about generating a big list of potential bugs or hypotheses. The goal here is to not miss any real clues.
So what happens in stage two? Do they bring in the senior detective?
Precisely. For the most promising hypotheses from stage one, Revelio calls in a much smarter, more capable, and more expensive AI. But its job isn't just to look at the code and agree. Its job is to provide cold, hard proof.
How does an AI provide proof that a bug is real?
It has to create what's called a proof of vulnerability, or POV. This is a specific input, like a specially crafted image file or a weirdly formatted text message, that is guaranteed to trigger the bug.
So it's not just saying, I think there's a bug here. It's saying, here is the exact silver bullet that will make this program crash, proving the bug exists.
Exactly. And here's the most important part. Revelio doesn't just trust the AI. It takes that silver bullet input and runs the program with a special diagnostic tool called a sanitizer. A sanitizer is like an ultra-sensitive alarm system for memory. If the alarm goes off, the bug is 100% confirmed. No guessing, no hallucination.
That verification step sounds critical. It gets rid of the hallucination problem completely. So did it work?
It worked spectacularly. The researchers tested Revelio on 7 major real-world software projects. These aren't toy programs. These are systems that have been continuously tested with fuzzing for 5 to 8 years. They're supposed to be very secure.
And what did Revelio find?
It discovered 19 previously unknown real memory safety vulnerabilities. These are what we call 0 days. 7 of them were serious enough to be assigned official CVEs, which are public security vulnerability identifiers.
Wow, it found 19 new bugs in software everyone thought was safe. That must have been expensive, right? Using all those AIs?
This is the other amazing part. The total cost to find all 19 of those vulnerabilities across all 7 projects was just $300.
$300? That is unbelievably cheap for this kind of security audit.
It's a game changer. They also tested it on a standard benchmark of code with known bugs. Revelio found 175 vulnerabilities, while other advanced AI coding agents, given the same task, found around 40 or 50. And Revelio did it with 0 false positives. Every single bug it reported was real and provable.
That's the key takeaway, isn't it? It's not just that AI can find bugs, it's about building a smart system around the AI, a system that uses cheap models for broad searches and expensive models for deep proof, and then insists on a final non-AI deterministic check.
That's it. It makes AI-powered security auditing practical. Developers can trust the results because every bug report comes with a receipt, the proof of vulnerability. It's a tool that can make the software we all rely on significantly safer without breaking the bank or drowning developers in false alarms.
So, Revelio's two-stage prove-it approach shows a much smarter way to use AI for cybersecurity. It's efficient, effective, and, best of all, trustworthy.
A huge step forward for finding those sneaky bugs before the hackers do.